Integer overflow explained in simple terms. Computers have to store numbers, and there are a lot of ways on how to do that. The most common method is to use an integer variable. Integers consist of 32 bits, where every bit can either be a 0 or a 1. Every flipped bit, or digit, as shown here, means increasing the number. The largest possible number this way is 2 to the power of 32, or about 4.29 billion. Most games though use a signed integer, meaning the highest bit, the bit on the far left, is used to indicate whether or not the number is positive rather than to count. 0 means the number is positive, 1 means the number is negative. Therefore, the number now ranges from negative 2 to the power of 31 to positive 2 to the power of 31 minus 1, or roughly 2.14 billion to both sides. But what happens if we try to store a number larger than the largest possible number? Think of it like this. We humans count in base 10, so if we have the number 9 and try to add 1, there's no way to represent 10 inside of a single digit. So instead, we overflow the first digit back to 0 and carry the 1 to the next digit. Computers do the exact same, except they only have 2 numbers per digit. Let's say we have an unsigned integer and have all bits set to 1. The game doesn't care if there are bits to the left or not and simply pretends as if it wasn't a problem. So, if we add 1 to this number, all bits flip and carry over to the next highest, all the way until we reach the most significant bit, which gets flipped to 0. They carry it over 1 from that, well, it gets lost. Since we only have 32 bits and not 33 or more, we made the counter overflow past the 32nd digit, wrapping all the way around from the highest possible number to the smallest. This also works the other way around. If we have all bits set to 0 and then remove 1, we underflow the counter and wrap around from the smallest possible number to the highest. This also explains why for signed integers the number suddenly turns negative. The most significant bit was never meant to count, so when we overflow to that digit, the bit simply sets itself to 1, telling the computer that this number is now negative. Most other number types also have this issue, you just simply hear about integers a lot more as they're the most common type by far. So in short, an integer overflow is a non-fatal case where the game tried to add a value to a number that's already at the maximum, causing it to wrap around to the opposite end of the number spectrum.